Imagine five board certified doctors reviewing the same medical scan. Three say cancer, two say benign. All have valid reasoning based on different diagnostic frameworks. All are experts. Now, here's the question that should terrify every AI executive. Which label goes into your training data? Scale this to millions of disagreements across finance, healthcare, strategy, and policy. When you train AI on the entire internet where experts legitimately disagree, which version of reality does your AI learn? I am Pattabhiraman Srinivasan, and I've spent the past several months researching what I call the AI Epistemic Trap, a hidden governance gap that's costing organizations millions and threatening AI investments worldwide. This isn't about data quality, it's not about bias, it's about something deeper. The philosophical choices your AI makes that nobody's even aware of. Let me show you what I mean. Let me give you real examples of contested domains where both sides are legitimately correct. In medicine, do you treat aggressively or conservatively? The do no harm framework says minimize intervention, the aggressive treatment framework says act decisively. Both have decades of evidence supporting them. In finance, do you diversify risk across your portfolio or concentrate for maximum returns? Ask two prominent investors, one who built wealth through concentrated bets, another through systematic diversification. Both are extraordinarily successful. Both will give you different answers based on their lived experience and what worked in their context. And both are right. In hiring, do you hire for culture fit or diversity of thought? One framework optimizes for cohesion, the other optimizes for innovation. Both work in different strategic contexts. Here's what your AI doesn't understand. These aren't measurement errors you can clean away. These aren't bugs in your data. These are irreducible framework disagreements. And when your AI encounters them in production, it makes a choice. The question is, do you know which choice it's making? Not all disagreements are the same. Understanding this is critical. Type 1 measurement disagreement. Two thermometers show different temperatures. This is solvable. Better instruments, better calibration. Data cleaning fixes this. Type 2 methodological disagreement. Different statistical methods on the same data. Should we use p less than 0.05 or 0.01? This is reducible. Standardize your protocols. Type 3 framework disagreement. This is the killer. Value investing versus growth investing. Both work, both have evidence, both are internally consistent, both are taught at top business schools. This isn't noise you can filter out. This is legitimate expert disagreement about how reality works. Traditional AI approaches assume type 1 and 2. Almost nobody is addressing type 3. This brings us to the AI epistemic trap framework. Here's what's happening. Your AI is trained on the sum of all human knowledge, everything on the internet. I call this sigma K. On one side, you have worldview A, aggressive growth, move fast, break things, prioritize rapid innovation. On the other side, worldview B, risk mitigation, measure twice, cut once, avoid errors at all costs. Both worldviews exist in your training data. Both are labeled as true. Both have peer reviewed research supporting them. Both have been successful in real world applications. So, when your AI encounters a decision in the contested domain, right here in the middle, it has to make what I call the latent choice. Which philosophical framework does it follow? Most of the time, it defaults to whatever appeared most frequently in the training data. It picks the majority view, the global average. But here's the trap. What if your organization needs the minority framework? What if your strategic context requires risk mitigation, but the internet's consensus leans toward aggressive growth? I formalize this as delta E equals the norm of sigma k times P average minus E phi omega. Let me translate that from math into English. The left side, sigma k times P average, represents what your AI learned from the internet, the global consensus, the most common pattern in the training data. The right side, E phi omega, represents your strategic framework, the expert opinion that applies to your specific context. What you actually need. Delta E is the gap, The epistemic divergence. How far your AI's default answer is from what your organization actually requires. The larger this gap, the greater your hidden risk. Now, this formula is conceptual. It's not something you can compute directly like a loss function. Think of it more like a framework for thinking about alignment. It helps us quantify and reason about something that's usually invisible. In practice, you'd operationalize this by measuring the distance between your AI's framework choice and your organizational requirements. But the key insight is this gap exists, it's measurable in principle, and most organizations aren't even aware it's there. Not all AI applications carry the same epistemic risk. That's why I created the AI governance risk matrix. The vertical axis is strategic impact. How important is this decision? The horizontal axis is data verifiability. How clear are the facts? Bottom right quadrant, data driven solutions, high verifiability, low impact, demand forecasting, process automation, pattern recognition. Traditional AI works great here. This is the safe zone. Top left, ambiguous strategy, low verifiability, high impact, emerging market entry, innovation bets. These need human judgment and scenario planning. Bottom left, low risk, routine decisions, stable patterns, scheduling, basic categorization, rule based systems work fine. And then there's the top right, the danger zone, high strategic impact and high data availability. This is where you think you're safe because you have lots of data. Medical diagnosis, investment allocation, policy recommendations. But here's the trap. Having lots of data doesn't help if that data contains multiple contradictory frameworks, all marked as true. Most organizations assume they're operating in the blue quadrant. Reality. Many critical decisions fall in the red danger zone without anyone realizing it. Let me walk you through a real pattern I've observed. I'll call it a composite case study to protect specific identities. But this dynamic has played out across multiple investment firms. A mid-sized investment firm deploys an AI to optimize portfolio allocation for retirement accounts. The AI is trained on 50 years of market data, including both value investing and growth investing strategies, both with proven track records. March 2024, market volatility spikes unexpectedly. The AI must decide hold positions aggressively or rebalance defensively. Here's what was in the training data. Framework A, growth investing, appeared in 55% of historical examples. The philosophy volatility equals opportunity, buy the dip, compound growth over time. Framework B, value and conservative approaches, appeared in 45% of examples. The philosophy volatility equals risk, preserve capital, protect the downside. The AI chose framework A, aggressive buying during the dip, with 87% confidence. Why? Because it appeared more frequently in the training data. The AI was doing exactly what it was trained to do, find the most common historical pattern. But here's what the AI couldn't know without being explicitly told. The firm's strategic mandate was preserve capital for retirees with 5-year horizons. This context required framework B, risk mitigation, not framework A. The right question wasn't what's historically optimal. It was what's optimal for OUR client base in this context. The outcome, the AI was accurate by historical standards, 87% confidence based on past data, but strategically misaligned with the firm's actual risk mandate. Delta E was high, large epistemic divergence between what the internet's consensus suggested and what this specific organization needed. The market downturn lasted 18 months, not the typical 3 to 6 month dip the AI had learned from history. Before manual intervention, this misalignment resulted in significant client losses in the tens of millions of dollars. To be clear, this wasn't bad data quality, this wasn't poor model performance, this wasn't a technical limitation. The actual cause was epistemic framework misalignment. The AI defaulted to the global average approach instead of recognizing the contextual need for the risk mitigating framework weighted for their specific client base. So, what do we do about this? I have developed a 5-step epistemic stress test. Step 1, domain risk assessment. Identify where your AI operates in contested knowledge domains. Ask, do subject matter experts ever legitimately disagree? Are there multiple schools of thought with supporting evidence? Do optimal decisions depend on context or values? If you answer yes to two or more of these, you're in medium to high epistemic risk territory. Step 2, Framework enumeration. For high risk domains, map out all the competing valid frameworks. Document each school of thought, its core principles, the context where it's optimal, and the supporting evidence. For example, in investment AI, you document value investing, growth investing, and index investing as three distinct valid frameworks, each optimal in different contexts. The key recognition, all three are simultaneously valid. The right choice depends on client context, not historical data alone. This creates a framework library your AI can reference when making decisions. Step 3, Context recognition testing. Verify your AI can detect when context shifts require different frameworks. Create test scenarios where the input data is identical, but the strategic context differs and the optimal framework changes. For example, same candidate profile, but one context is a tech startup needing disruption, the other is a bank needing regulatory compliance. The AI should recommend differently based on context, not just the resume data. Step 4, Epistemic divergence measurement. Quantify delta E, the gap between your AI's learned framework and your strategic intent. For each decision, identify which framework the AI chose, identify which framework your strategy requires, and measure the distance. Set decision thresholds. Low divergence, proceed automatically. Medium, flag for review. High, require human approval. If 40% of your medical AI's decisions have high delta E, your AI is systematically applying the wrong treatment framework for your patient population. Step 5, Meta governance implementation. Build AI that navigates frameworks, not just memorizes patterns. Instead of one model asking what's the most likely answer, you build a multi framework system asking which framework applies in this context. The architecture has three layers. Layer 1, Framework specific models. Instead of one model, build multiple, each trained on a specific framework's examples only. Layer 2, Context recognition module. A meta classifier that determines, given your business context, which framework applies. It considers strategic priorities, risk tolerance, time horizon, and stakeholder profile. Layer 3, Meta principles and human AI collaboration, rules for when AI should defer to human judgment. The critical capability, your AI must report two types of uncertainty. Traditional AI reports, I am 67% confident in this prediction. That's aleatoric uncertainty, data uncertainty. But epistemic robust AI also reports, I am uncertain which framework applies here. Delta E is zero point 0.8. The critical difference, traditional AI can be highly confident 95% while using the wrong framework. Epistemic robust AI flags, I'm 95% confident given framework A, but delta E suggests framework B may be more appropriate for your context. Here's the reality. Most enterprise AI systems today score 0 or 1 out of 5 on the epistemic stress test. They pass traditional tests, accuracy, explainability, fairness, but they fail the epistemic stress test. They're epistemic brittle, not epistemic robust. And that's dangerous when operating in contested domains. The good news, this is addressable. You can start by auditing your AI systems, identifying high risk domains, and implementing framework awareness. I've published the complete framework, including implementation roadmaps, assessment scorecards, and detailed methodologies as a research paper. It's available on Zenodo now and will be on SSRN shortly. The link is in the description below. This is the first publication from what I am now calling Wisgrow research, my effort to address critical gaps in how we think about AI governance, epistemology, and systems operating under uncertainty. If you're working on AI governance, if you're deploying AI in high stakes contested domains, or if you're just interested in how AI makes decisions when there's no single right answer, I'd love to hear your thoughts. Comment below Connect with me on LinkedIn, and let's figure out how to build AI that doesn't just optimize for accuracy but aligns with strategic intent. Thanks for watching, and remember, the most dangerous AI isn't the one that's wrong, it's the one that's confidently applying the wrong framework.